equals x plus 2, x take 1. We have two critical numbers. On the top, x equals minus 2. This would cause a so-called 0. We have, underneath that, in the denominator, our problem when x equals 1. This would cause a divide by 0 or asymptote. So this is the algebra that would cause when x equals 1. This is the algebra that would cause this shape. Okay, when x equals 1, we're going to have asymptote. See the correct spelling in the book. It gets a bit fuzzy with the big texters, but yes, obviously when I have 1, take 1, it's going to cause a 0 on the bottom. Any number divided by 0 is going to cause an issue. On your calculator, we'll say error. When we're graphing it, we'll say the function doesn't exist at this point. This is the whole key to these questions. Something's going to happen at minus 3. Something's going to happen at plus 1. The rest of this is much the same. F, X. So my two numbers of interest are minus 2 and 1. Now I've worked this one out in my head and you can see what's happening here at the minus 2. Okay, so if you graph this into the calculator, you would be able to generate this set. I'm going to use it with the algebra now. So in other words, I just said that that's what's happening at minus 2. Now to use the algebra, let's choose a number out here. F of minus 5 equals minus 5 plus 2 minus 5 minus 1, which would be minus 3 over minus 6. This is a positive value. Let's choose f of 0, so in between here, would equal 0 plus 2 over 0 minus 1 is a negative value. Let's choose f of 10, which would be out here. 10 plus 2 over 10 take 1 is 12 over 9 is a positive value. So again, briefly, I have this happening, and the way we indicate that asymptote is that when you look in the book for rational functions, this is a dotted line, where this is the coloured in line. So it changes from positive to negative at 2, minus 2. This goes down. Well, I'll just redraw that. Change from positive to negative at minus 2. And when it's hitting 1, it's for there ever positive. Now, you get the experience from seeing a few of these. If this is going to be positive, it's going to have some sort of shape like this where it gets closer to 0 but not equal to 0. So this is a rational function. This particular question here will look very similar, except this will stand for a 0, and this one here will have a dotted line at when x equals minus 3. Have a look at some of the examples in the book.